Let's look at factoring polynomials that are quadratic in form. So for example, x to the fourth minus 7x squared plus 12. This is a quartic trinomial that looks similar to trinomials that we have factored that were quadratic, but this isn't quadratic because I have an x to the fourth. But I'm going to take my middle variable expression, x squared, and set it equal to some other variable. That it can be anything but not x, since that's the variable that's in our original expression. So I'm going to use u. So I'm going to set u equal to x squared, and then u squared would be x squared squared, which is x to the fourth, which happens to be our first term. Otherwise, we couldn't continue using this method. So x to the fourth, I'm going to replace with u squared. Minus 7x squared, I'll replace x squared with u, so minus 7u. And plus 12 stays the same. So now we have u squared minus 7u plus 12, which is quadratic, and we know how to factor this. So I can make an x. I'm looking for numbers that multiply to 12 and add up to negative 7. Those numbers would be negative 3 and negative 4. The coefficient of u squared is 1, so I can go right to parentheses, and this factors to u minus 3 times u minus 4. And now we'll substitute back. Instead of u, I'm going to write x squared minus 3, and then x squared minus 4. And it looks like we're factored, but of course, we need to see if we can factor anything further. So x squared minus 3 is a difference of two terms. One of them is a perfect square, but the other one isn't, so we're not going to factor that one. We'll leave it alone. But x squared minus 4 is the difference of two perfect squares, so we can factor that into x plus 2, x minus 2. And we'll bring, of course, down the x squared minus 3. So x to the fourth minus 7x squared plus 12 factors to x squared minus 3 times x plus 2 times x minus 2. And we have two linear factors, the x plus 2 and the x minus 2. And we have one quadratic factor, and that is the x squared minus 3. Let's look at a second example. So here, this one looks a little different. I have 3x plus 1 parentheses squared plus 3 times 3x plus 1 plus 2. So this isn't a quartic or a cubic, but I wanted to at least show you some other example where you could also use this method. And you'd be tempted probably to multiply everything out, like 3x plus 1 times 3x plus 1, and then distribute the 3, and combine your like terms. But we're going to try to see if we can use this method on we can consider this a trinomial as well. So I will set a variable equal to 3x plus 1, which is my middle term variable expression. So u equals 3x plus 1. That means u squared will equal 3x plus 1 quantity squared. And now we'll substitute. So instead of 3x plus 1 quantity squared, I'm going to write u squared plus 3 times u plus 2. And now we have u squared plus 3u plus 2, which we know how to factor. We're looking for numbers that multiply to 2 and add up to 3. Those numbers could be 2 and 1. So this factors to u plus 2 times u plus 1. But what is u? U is 3x plus 1. So let's substitute that back in for u. So I have 3x plus 1 plus 2 times 3x plus 1 plus 1. And let's simplify that a little bit by combining my like terms. So we have 3x plus 3 times 3x plus 2. Can anything be factored further? Yes, I have a GCF in this first binomial expression. I can factor out a 3, and then 3x divided by 3 is x, and 3 divided by 3 is 1. And then 3x plus 2 does not factor further, so we bring it down. So now we factored example 2 to 3 times x plus 1 times 3x plus 2. And we have two linear factors, the x plus 1 and the 3x plus 2. Let's look at a third example. Here I have 2x to the fourth minus 5x squared minus 12. So this is very similar to our first example where I set u equal to x squared. And u squared will equal x to the fourth, which is our first variable expression. So let's continue trying to use this method. So instead of x to the fourth, I'll put u squared, and instead of x squared, I'll put u. That makes this 2u squared minus 5u minus 12. And we know how to factor this. I'm looking for numbers that multiply to 2 times negative 12 or multiply to negative 24 and add up to negative 5. And those numbers are negative 8 and positive 3. So because we do have a coefficient of my quadratic term that is not 1, we will have to expand out the middle and use factoring by grouping. So I've got 2u squared minus 8u plus 3u minus 12. So now using factoring by grouping, the GCF of my first two terms is 2u. 2u squared divided by 2u is u. Negative 8u divided by 2u is negative 4. And then let's look at our third and fourth terms. 3u minus 12, my GCF, my greatest common factor, is 3. Because my third term is positive, it's positive 3. And then 3u minus 12, if I divide both of those terms by 3, I have u minus 4. Now we have a common binomial term. Let's factor that out, u minus 4. And then in my second parentheses, I've got my two greatest common factors, my 2u plus 3. And now let's substitute back. So instead of u, let's substitute in x squared. So we've got x squared minus 4 and 2x squared plus 3 as my factors. Can anything be factored further? Well, here I have the difference of two perfect squares. So I've got two sets of parentheses I can break it into. Square root of x squared is x. The square root of 4 is 2. One gets a plus, one gets a minus. And then 2x squared plus 3 does not factor further, so we will bring it down. So example 3 factored to 3 factors, x plus 2 times x minus 2 times 2x squared plus 3. So I've got two linear factors, x plus 2 and x minus 2, and one quadratic factor, which was 2x squared plus 3.